now is that it's possible that the shapes could have the same volume but have different surface areas depending on the arrangement of those blocks. Now, something that mathematicians get really interested in is a concept called optimization. Okay? Optimization means finding maximum possible values and minimum possible values for any kind of situation like this. Okay? So today, your problem is going to be one where you're going to be doing some optimization. Okay? At the heart of the problem that you're going to be working today is this question. Okay? If you take 64 blocks, okay, just like I did with these, and make these three shapes, okay, which shape of all the different rectangular prisms that you can make out of 64 blocks, which shape would have the smallest surface area? Okay. So that's really the question that's at the heart of what it is that we're going to do today. Okay? So I'm going to hand out your problem, and your problem sort of is going to get you to start thinking about, okay, how you would go about finding the shape that has the smallest surface area overall. Okay, so I'm going to give you 3 minutes, please. 3 minutes to get some thinking down, some problem solving. And you'll note here that in the problem, it doesn't say you have to work with 64. It just says a rectangular prism with a fixed volume. So if you are not crazy about the number 64 and you want to choose a different number, a number you might feel is easier to work with, okay, then that is your choice. Can you now spend 3 minutes, please, just with some personal solving time? So without consulting your partner now, this is your chance to really get some ideas down on the page, okay, so that when you come back together with your partner, you'll be able to share some thinking and really move forward on the problem.
Well, I think the cube is always going to be small. And different, like, use the same amount of blocks for, like,
please. Okay, go. Can you explain again what it was that the way that you're thinking about surface area, that the way that you said it to
Oh no,
Morgan?
it would be 64, I think. Okay, well, 4 times 4, 1, 2, 3, 4, 1, 2, 3, 4. So one side would equal 16.
Okay, I'm just going to interrupt for a second. What about that side is equal to 16?
Length
times width.
Yeah.
equals area.
Ah.
And you do the area of each
And that's
side.
a keyword, because when we do the measurement, we're measuring an attribute of something, right? So the attribute that's being measured is the area of that surface, of that side. Okay?
We'd have to times it by 6.
Yeah, because there's 6 sides.
Okay,
Yeah, I
why?
was gonna say because there's 6 sides of it. We want to find the area of like the whole thing.
Okay, and originally what were you doing?
I was just doing length times width times height, that equals volume.
Okay, so Dakota, I just want to make sure that everybody in your group is ready to continue with the chart. So can you explain how to calculate the surface area of this cube, please?
Okay. Length times width, right?
Okay.
Which is 4 by 4, which is 16.
Okay.
Then you go, so basically each side is 16. So that's 6 sides. So 16 times 6, you get the surface area.
Then when it's a rectangle, that doesn't work because like
Yes,
you're gonna
then you
have
have to
do
calculate
sides,
all
right?
the sides, like one on the side.
So you
Two
like,
sides and then 4 sides.
because like you could do like the length, like if you, because like if there's like 3 parts of the rectangle that are all different, but then they have a equivalent one on the other side, so you could just find like the area of 3 and then times those each by 2.
I know what you mean.
What do we think of that?
I'm in agreement.
Good.
Okay. Okay, so that's an interesting theory. So once the guys get a new cube assembled, then you can sort of, or a new rectangular prism assembled, you can test that. Okay? All right. So you guys, we have some of our group that's got our chart filled out, and the rest of the group doesn't. So Josh, what I'm going to ask you to do is, can you explain where you got these numbers for the surface area column, please?
Okay. For the cube, it was really easy because all the sides would be 4 by 4, so I multiplied 4 times 4, so that's 16, and then I multiplied that by 6 for each side, and then I got the surface area.
Okay, what I want you guys to do, okay, as a group, because you need to be together on this, right? So you should be working cooperatively to help Phil to work on the chart. And it's not okay that one person in your group can sort of say a definition for how he got surface area and the rest of the group not understand where that came from, okay? So Josh, maybe it's either going to take that you go back to the cube and you rebuild the cube and you actually point out, Josh, where this is coming from. Because when you say 4 by 4 times 6, I don't know if your group knows where that's all coming from. Okay. For instance, Tamer, can you describe where 4 by 4 times 6 is coming from on the cube?
I can.
Well, I need it.
I can. It's right there.
Okay, so what I need is I need you as a group, because this is a part of working in a group, right? Each person of the group has to be able to explain and understand the work that you've done. So I need you to be able to explain where 4x4x6 is coming from, especially since the length, the width, and height are all 4s.
Length times width times how many sides are on the
Yeah, like you do like 10 width times height, and I would times 6 over 6 sides.
Okay. So how does that work on the shape? Like, could you explain how that works on the shape?
Because if like you find the area of one side and you multiply it by 6 because there's 6 sides, you get the total surface area.
And all the sides are the same.
Yeah, because in a cube, all the sides are the same. It's equal.
Okay. Morgan, can you explain where the surface area 54 is coming from for that cube
So we
piece?
just found the area of each base, which is 9, and then we just times it by 6 bases.
Okay, why times it by 6?
Because the cube has 6 bases.
Okay. All right, keep going, Dylan.
And then for our next shape, we did a length of 27 and a width of 1 and 1.
Okay.
And a height of 1, so it would just be one really long stretched out piece.
Yes.
And we counted, because it has 4 sides, 4 faces of 27, so we times 27 by 4, which got us 108, and then the 2 end pieces we added, which got us 110. The surface area.
Now, did you actually make that shape?
Yeah.
In order to confirm that those 4 sides are the same and you've got those 2?
Yeah.
We are getting to the end of your time, your allotted time, that you can continue to investigate and explore the problem. Now, here's 2 things. Okay? In the next couple of minutes, we're going to come back together, and I'm going to be asking some groups to present their findings, to present their thinking. I'm going to be coming around. I'm going to give your table a chart paper and a marker, and I would like you, in these last few minutes, to summarize what it is that your group has discovered. You're going to have 5 minutes to make your chart paper, and then we're going to begin with our Congress. Okay?
78. And the next one is 13.5. 1, 2, 85.
Okay. Rob. Why?
And the longer the length, the greater the surface.
No, it's L-O-N-G.
Lisa? How's that name, Lisa?
So, one of the things that I'd like for us to move into now is our debrief. And so I've gone around and I'm just taking a look at your charts. I've selected a few charts that I think I'd like for us to show and highlight in terms of what we've discovered in terms of the problem. And so I'm going to ask a few groups to come up and share their thinking and share their work with us. Okay? While we're in this process, this is a time for you to be thinking, listening carefully, thinking thoughtfully about what you're hearing, okay? And also thinking about any questions that you might have. What questions might you have for this group, okay? What questions might you have about what they did or where we're going to go with this next, okay? So the first group that I'd like to come up and share their thinking, please, is our middle table here at the back. So if you folks can come up with your chart paper and share with us, please, what it is that you found. So the group can start when they can see that the audience is ready.
We thought that the cube had the smallest surface area because we did the equations and it turned out to be like that. And the cubes have cubes inside that you can't see.
Can we have a few members of your group explain what information is on your chart paper there that is evidence that the cube has the smallest surface area?
Well, we took the same volume for each one, but we had different length, width, and height. And so the surface area came out different for each one, but the volume stayed the same.
And we did the equations to figure out the surface area.
Yeah. So each one.
Number 3 is right there. And we did 16 times 2 because that's the area of one side, and we multiplied it by 4 because there's 4 sides with that area. And we did 2 times 2 because those are the sides on the side. And we found that area, we multiplied it by 2 because there's 2 sides of it, and we added it together.
Okay, thank you.
Just 2 blocks side by side, but then the volume is 64, so it won't work.
Okay, thank you. And Carly, you commented on that. What was your concern about that, the idea that we could just put 2 blocks side by side?
Well, the volume of that wouldn't equal 64, and for this one, we're saying that the volume has to be 64, and if the volume is 64, the lowest possible surface area is 96. So we can't really just use 2 blocks because that's not a volume of 64.
Okay, thank you. Okay, thank you, group. You can have a seat. The next thing that I would like to explore in a little bit more detail is that it might be true just for blocks when we have 64 blocks. Is it possible? Okay. Is this true when we have a fewer number of blocks? So there is a group that did explore a different number other than 64, and I'm going to ask them to come up and share their thinking. So if this table can come up and share with us what they found, please.
We did a volume of 27, and we made a cube first, and our length was 3, our width was 3, and our height was 3, and our surface area was 54, and then we did a length of 27, width of 1, and a height of 1. We got 110, and then we did length of 9, width of 1. Height of 3 and 78, and then we did length of 13.5, width of 1, height of 2, and then we did length of 54, width of 0.5, and height of 1, and 163.
Okay, thank you, group. Mike, you believe that your work
Supports the cube is the smallest.
Okay, so can you show us where on your work that is being supported?
Well, also over here, I just did a ratio for how many blocks are actually affecting the overall surface area. So for the cube, there's that 1 square in the middle that isn't affecting it. So I minus that from 27, which is 26. So I did 26 divided by 27, and I got 96.2. So that's the percentage of how many blocks are actually affecting the final surface area. But for all the other ones, 100% of the blocks are touching the outside. So yeah, this is the smallest ratio that we could find for how many blocks are touching the outside.
Okay. Thank you, Dylan. And based upon that work that you've done, what conclusion has your group come to?
The longer the length, the greater the surface area will be.
Okay.
From what you've seen from the first presentation and now the second presentation, are you convinced? Is this enough evidence for you to say, yes, Mr. Perry, in all cases, the cube will always be the one that has the smallest surface area? Let's just do a quick little survey. So, can you give me a thumbs up? Yes, this is enough information. A thumbs down if no, you're not convinced. You actually are not sure if it's always going to be true based upon what you've seen. Okay. Can you show me right now, please? Vote now. Okay. Let me restate the question just to make sure that we're clear. Okay. You are giving me a thumbs up if you've seen enough information and enough. So can everybody just direct their attention to the front again and take a look at their concluding statement? Read that to yourself just one time quick.
It says the longer the length, the greater the surface area will be.
That kind of statement sounds a lot like a relationship statement from previously in the course with us, right? It sounds almost like a correlation kind of statement, right? As the length gets greater, the surface area will be, right? It's like one of those hypotheses that we test when we're looking for relationships, okay? So our next direction is going to be actually looking at that to see if there is a relationship. Is the statement there that's being made, that hypothesis, can we actually find a relationship between the length of the side and the surface area of the shape? Okay?